Alright, in our previous video we finished question number 16. So let's go ahead and go to the back side of this page, of your first review page. Here is question number 17. Question number 17. Convert the equation y equals 2 times x minus 3 times x plus 10 to standard form by distributing. Class, this is intercept form. We're going to change it to standard form by distribution. So let's go through these steps. The first step is you got to distribute the 2 into the first binomial. So 2 times x is 2x. Oh, I don't know why I wrote a parenthesis there. Let's try that again. 2x. 2 times negative 3 is negative 6. This becomes a new binomial. And we're going to multiply that by x plus 10. Next step, we're going to take the 2x, and that's going to distribute to the second binomial. So we've got 2x is going to be distributed to the x plus 10. And then the negative 6 is going to also be distributed to the x plus 10. We've done this many times before. This is found in your polynomials flipbook. The next step is, let's multiply the monomial times the binomial. 2x times x is 2x squared. 2x times 10 is 20x. Next group, the negative 6 to the x. Negative 6 times x is negative 6x. Negative 6 times 10 is negative 60. Be careful there, class. A lot of you will do the mental math and say negative 16. Some of you will also go, oh, negative 6 plus 10 is positive 4. Be careful. We are distributing the 6 to the terms. That means it's negative 6 times x and negative 6 times 10. Remember, class, when we use this method, the middle two terms are always common terms. And that's going to be, let's write our final equation right here. Y is equal to 2x squared positive 20 minus 6, positive 20x minus 6x is positive 14x. And then we have the negative 60 on the end. Question number 18 is just the same thing. We're going to practice it again. Let's go through these steps. The first thing we're going to do is we're going to distribute the negative 4 into the first binomial. Negative 4 times x is negative 4x. Negative 4 times 6 is negative 24. That becomes a new binomial. We're going to multiply it by the x plus 9. Now we take the negative 4x. That's going to now distribute to the x plus 9. And then we have a negative 24. And that's going to distribute to the x plus 9. Now again, we have monomials and binomials. We'll distribute those. Negative 4x times x is negative 4x squared. Negative 4x times positive 9 is negative 36x. Negative 24 times x is negative 24x. And negative 24 times 9, check that out in your calculator, that is negative 216. Again, we have the two middle terms, our common terms. We can add those together, so our final equation is going to be y equals negative 4x squared. Negative 36 minus 24 is negative 60. Do that in your calculator if you don't have an easy time with negative numbers. It's in your calculator. Negative 36 minus 24. You'll get negative 60. And then our C value stays the same, 216. Alright, let's take a look and see how much more I can fit on this video. Let's try to do 19 and 20 and see if we can get that done. So, whoops. Go back. Alright. Number 19. Factor the equation y equals x squared minus 4x minus 12. Oh, I like this one because the a value is 1 That means we have a GCF of 1. Take a look at it. You've got coefficients of 1, -4, and -12. 1 is the smallest number, so there is no GCF to take out. We can identify A, B, and C and go right to our factoring. So A is equal to 1, B is equal to -4, C is equal to -12. Let's make our combination table and figure out our B terms. A times C is -12, B is -4. Let's go through our combos. 1 and 12, no good. 2 and 6, looks like we already got there. We need a -6 because we have -6 plus 2 is -4, and -6 times 2 is -12. There's our combination. In class, here's the good news for this one. Our A value is equal to 1. That means we can write the shortcut. Our factor form is just y equals x plus 2 times x minus 6. That 2 and that -6 came right from our combination in our I table. Alright, so that's 19. Let's go to number 20. I already know this is not as easy of a problem. We might have a hard time fitting all this work in. I'll do my best to fit it in here. We've got y equals 6x squared minus 21x minus 12. We have to factor this. Remember, class, factoring is just changing it into a different form, or called factored form. In this case, if this is actually intercept form, you're not solving. So don't try to find the x-intercepts. If it said solve, you'd have to go the next step and find the x values that change this equation to 0. But in this case, we're just doing the factoring. So factor this equation. Well, the first thing I'm going to look at is, what is the GCF? We're going to start with the smallest number, and that is 6. 6 goes into 12, looks good, but 6 does not go into 21. Let's try 5. 5 doesn't go into 6. How about 4? Nope. How about 3? 3 goes into 6. 3 goes into 21 7 times. 3 goes into 12 4 times. We found our GCF is 3. And because our A value is positive, we'll just pull out a positive 3. So this first step, we got to get the GCF out of here. So we're going to just go 3, and I'm going to use square brackets. What's left over? Looks like I've got 2x squared minus 7x minus 4. Class, do yourself a favor. Check your work now before you continue. 3 times 2x squared is 6x squared. 3 times -7x is -21x. And 3 times -4 is -12. That looks good. Now we can factor. Our A value now is 2. That means we can't use the shortcut method anymore. B equals -7 and C equals -4. Let's make our table. I'll try to squeeze it in right here if I can. A times C is 2 times -4, which is -8, and our B term is -7. I think we got our combination in the first try. 1 and 8. We've got a -8 plus 1 is -7, and -8 times 1 is -8. So there's our combination. Alright, let's go through the formal factoring steps. We're going to have to split our B term. That means we're going to have 2x squared. We repeat the first term. -7x is now going to become positive 1x, -8x, and then we repeat our third term, or our C term, -4. In this next step, class, we will look at the first two terms and pull out the greatest common factor. Look at the second two terms and pull out the greatest common factor. So I've got 3. Now in this case, look at the first two terms. Check the coefficients first. 2 and 1. Well, the GCF is just 1. But they both have an x value. In fact, they always will when you factor this way. So they have a common variable of x. What's left over? 2x plus 1. Let's check that and make sure. 1x times 2x is 2x squared. 1x times 1 is 1x. We're good with that one. Now take a look at the next two terms. Start with the GCF for the coefficient. We've got a 4 and an 8. 4 goes into 8. That means we have a GCF of 4, and the sign comes from the beginning of those second two terms. It's going to be a negative 4. What's our leftovers? Looks like it's 2x plus 1. Let's take a look. Negative 4 times 2x is negative 8x. Negative 4 times 1 is negative 4. We're good to go. And our two binomials that we found that were common are the same. That means we have a green light to do the next step. Next step, we'll actually wrap it up. In fact, I can write my answer here in the next step. Y is going to be equal to 3. That was our GCF. Take a look at the two numbers that we were able to factor out. 1x and negative 4. I can just write x instead of 1x. So x minus 4 and 2x plus 1. X minus 4 and 2x plus 1. And don't forget that. Don't forget the y equals and then the GCF in the front. Alright, we're almost done. We got about 3 minutes to go. Let's finish the last two. 21 and 22 are asking you to find or estimate the x-intercepts from the graph. We'll just take a look. Where does the graph touch the x-axis? So it looks like we have an x-intercept. Be careful here. Look at the scale. This is 0.5 and then, negative 0.5 and then negative 1. That means our first one is going to be at negative 0.5, comma 0. And then this is at 1, 2, 3, 4, 4.5. So we have an x-intercept at 4.5, comma 0. And question number 22, same thing. Take a look at our points. Looks like we got a point right here and a point right here. Look at our scale. Our x scale is by ones. So it looks like we have an x-intercept at negative 2, negative 4, negative 6. This is 4, 5, 6. That's 6.5. So it's at negative 6.50. And this one's at 1. It's halfway between 1 and 2. So it's about 1.50. So that's how we estimate x-intercepts based on the graph.